Okay, so here's another example where we have a ground in our circuit and we are trying to find the voltage at point B and point A. And what we know about the ground in our circuit is so in the last problem, it didn't really affect the current. We talked about how it didn't affect the current. But what it does is the point where the ground is connected, that point, um, the voltage is equal to 0. So V is equal to 0 essentially from here to here. So it doesn't change until we go across another component. So the ground just kind of sets a specific spot in our circuit equal to 0. This battery here is a 6-volt battery, or no, it's a 5-volt battery. All right, so the technique here is just like usual. Let's go ahead and pick a direction for current, and I think current would probably go this direction since the 15-volt battery is bigger. Okay, and so we're going to move in that direction starting from where the ground is located, and we are going to go ahead and figure out what that current is first. Okay, might as well just figure out what that current is. Okay, so we're starting at 0. Again, the ground starts us off at 0, so we're going to have 0. Anytime we go across a resistor, we're going to subtract. And so I'm going to go ahead and call this, we'll call this resistor 1 down here and resistor 2 up there. So we'll have 0 minus the voltage of resistor 1. We're going to add, so we're going from minus to positive. We are going from low potential to high potential, so we add that voltage. So we'll have plus the 15 volts. And then we subtract when we go across resistors, so we would have minus delta V of R2. And then we are going to have minus the voltage of the 5-volt battery, minus 5 volts. And at that point, we should be back to 0. So at that point, we should be back to 0. Okay, delta V of R1, this is going to be minus, we're going to have minus I times R1. I'm going to go ahead and add 15 volt minus 5 volts, so that gives us plus 10 volts. And then we have minus I times R2, all of that equals 0. I'm going to add I R1 and I R2 to the other side so that we get 10 volts. And this is equal to I times R1 plus R2. This is equal to I times R1 is 1 ohm, and then R2 is 4 ohms, so we get 5 ohms. And this equals 10 volts. Divide both sides by 5, and we get I is equal to 2 amps. So now I know the current going through that circuit, and so to figure out what the voltage is at point B and point A should be pretty easy now. So delta V of R1 again is current times resistance, so this is going to be the 2 amps times the 1 ohm. That gives us 2 volts. And delta V of resistor 2, delta V R2, this is going to equal 4 ohms times the 2 amps. That gives us 8 volts. Okay, so starting at the ground, when we go across this resistor here, we are going to subtract our voltage, right? So we're starting at 0. This is going to be, we're subtracting as we go in this direction. So at point B, we are actually going to be at a minus 2 volts. So V of B is minus 2 volts. When we go across the battery, we are going to add the voltage. So we are going to add or minus 2 plus 15, so we're at 13 volts now. And then as we go across this resistor, we will subtract 8 volts. So at point A, we are now at 5 volts. Okay, and that's all we needed to figure out. So this is V of A. V of A is 5 volts, V of B is minus 2 volts. And if we were to keep going, we would subtract this battery because we're going from positive to minus, high potential to low potential, and so we would end up at 0 volts, which is where we wanted to. So that works out. So potential or voltage at point A is 5 volts, potential at point B, -2 volts for that problem.